curing cancer, creating a new element, or even discovering extraterrestrials. It's all that matter of fact. But it's actually what physicists have been trying to get at is the theory of everything. It's supposed to be this grand theory that unifies all of physics, all theories from relative to quantum mechanics into one. And it will be able to answer the question to the very core of our existence down to the subatomic level. Now let's backtrack a little. One of George Lemaitre's theories stated that the universe was created by the Big Bang, where the universe was originally this small, and suddenly, trillions of years ago, it combusted into thousands and millions of galaxies and stars. And another theory by Martin Schwarzschild, which it proves the existence of a black hole, which is a vortex that its gravitational pull is so strong that it sucks anything nearby it, even light. And since it sucks in light, we can't see it. It's basically invisible. And you see, this is where those theories sort of explode on itself. It only shows us the existence of those things, but it doesn't show us what's beyond that. And that's where the theory of everything comes in. It answers the why, the how, and it goes even beyond. Why does a black hole exist? What's beyond the black hole? What's happened before the Big Bang? What happened the billionth of a billionth of a billionth of a second before the Big Bang? And the theory now, it goes even further by predicting that we live in a multiverse, where we live in a pocket universe amongst millions of other universes near us that have in their law of physics might be different, and ours might be different, and even the realities. So I want to tell you guys all that random info because this theory, to show how this theory is so grand that it covers all of physics. And due to how incomplete it is, I will tell you guys how only the four forces that sort of frames this theory and what we know, and what happens when we do know the theory of everything. So according to Captain Freeze from NYU, in the universe there are four fundamental forces that run the universe that we know: electromagnetic, strong nuclear, weak nuclear, and gravitational. Mind you, we only understand them. We haven't mastered them yet. And just by understanding them, we achieve what we have today. And let's start with gravitational. About 200 or so years ago, Isaac Newton first wrote about the laws of gravity from the fallen apple. Then a few years later, it gave us locomotives, skyscrapers, steam engines, and it was essentially the backbone of the Industrial Revolution. Same thing with electromagnetic. When physicists finally worked out what powers up our room, phones, computers, the technological advances double. Then there's the third and fourth force, weak and strong nuclear. When it was finally worked out in the last century, it gave us the power of the stars. And it gave us the power to power the factories that supplies millions. But at the same time, it gave us the power to create weapons that could potentially destroy and kill millions. And what I wanted to link this together is how whenever we understand a bit more about these theories, the world changed. Our philosophy, our values, technology, politics, it all changes. And what scientists know is that these four theories, or these four forces, were there when the Big Bang happened. So that's how they linked. So this is one of the pieces of the puzzle that scientists actually been able to connect, but not all of it yet. So what happens when we really do find a theory of everything? Well, when we do, we'll be able to find all of the forces that actually runs the universe and be able to master all of the forces. And so you might be asking, okay, if we find a theory of everything, would tomorrow we have higher TV resolution? Would my car drive faster? Can I fly? Well, it wouldn't affect our lives directly. It's more of long term. Because when we find this theory, it would be pages and pages. Because it's a new branch of physics that we haven't even learned yet. So it would take many years until we can actually make anything. And other questions that people have brought up, okay, so you find a theory that sums up all of physics and connects No, it would branch out to potentially focus on space travel, maybe time travel, black holes, and changing particles all around.